This is the final concluding lecture of the MOOC series. I would like to summarize here whatever we have done so far in the whole 20 hours of video recording which had been shared with you. Unfortunately, due to pandemic, not everything could have been done in the studio. A lot of it actually has been done at my home on my laptop, so where the quality has degraded, but still we tried our best, and of course maybe in future we will actually have better versions of this. So the lecture, this whole series was about peer-to-peer systems, and idea was that to essentially sensitize people, to get them introduced that why this is required and why this is important. And the reason why actually I went to this, in fact this whole thing started with my development of Brihaspati system, which I did as a learning management system for on a web-based as a web portal, and this is what actually runs on brihaspati.nmeict.in. And at some point of time I figured out that you can't scale it massively, and that's when my interest actually grew in peer-to-peer systems, and I studied them, and we started this project on Brihaspati 4. And during all that process, when I was learning, I taught as a course and then thought of giving it as a MOOC. And I figured out that not many people are aware of it, not many people know that this how it can be used and what are the powers which are going to be derived out of the application of this system. Now, one of the biggest thing which I see is that you can actually scale, the whole system scales as more number of users grow. It becomes better and better as more and more users come into the system. And there are actually again two kind of systems. One are structured, other one is unstructured. We have talked about them earlier in the beginning. And in any structured system, idea is that we have unique node IDs, and that's where the distributed hash table actually comes into picture. And then there is a whole mathematics that they can be all assumed to be like placed somewhere in the hash ID space, and they become responsible for some of the key value pairs, and so there is being a unique mapping. In henceforth, if you want to search for some key value pair, technically computing is all have to do about finding out from whom to get the resource. There's always a key and value. Key always tells what resource you are trying to find out, and value tells from where you can get it actually. So the idea came from there that DHT algorithms can be used. And then we had talked about voice over IP system, we have talked about distributed file system, so how that actually becomes important. And the DFS was a remarkable idea which we have worked upon, is that all users extra resources which they actually get now with their own machines, because their machines are pretty powerful and not every user using it, we can actually build up a collaboration between the machines. And that idea came up with the DFS, and of course with that came all kind of security, the resilience mechanism. Okay, and so we had talked about that stuff during the MOOC. We had talked about overlaid multicasting, so whereby live streaming systems actually can also be built. We have talked about the onion services, which we have done in the last, the hidden systems. There's a lot of things which have been left out, which have not been covered. For example, delay tolerant networks also comes in the same category, where there is no internet or there is no underlying communication infrastructure. When you come in communication in the proximity of somebody, you communicate. That guy comes in proximity with somebody, it communicates. Now that's also another interesting actually domain which can be explored here, which have remained unexplored. There have been search engines, how to create them, we have explored them. I have actually talked about search engines in the MOOC. So let's jot down what all we actually have done. So we started with a DHT based system. We looked into a lot of DHT algorithms. Typically I talked about chord, their stability, how to define the distances. Okay, we talked about tapestry. Okay, we talked about Kademlia. We talked about pastry, and during pastry thing we actually figured out how the neighbor's proximity in terms of round trip delay time can also be involved, which was not possible in chord. We have talked about tapestry chord hybrid. which has been used in Brihaspati 4 implementation. Okay, we have talked about distances. Then we have talked about multi-dimensional DHT, which was kind of a new thing for me. And so mathematically we were able to establish a generic thing. We also have looked into why we require sometimes what we call the leaf sets. So your neighborhood information, why that is important. So simply having logarithmic partition may not be sometimes good enough. Okay, so you need that for a stable routing system. So we have proved that such a scenario, that why you need leaf set. Without leaf set you may not be able to go to have the optimum configuration. You may never be able to reach to the road sometimes, even if when it is existing. Okay, so this was all behind the mathematics. We have talked about unstructured system. So as I mentioned earlier, DFS we have done overlaid multicasting. So I am now not doing it, putting it in order, just whatever I am recalling, I am writing it down. And I will also mention what we have not done. So delay tolerant networks we have not done. So those actually very well come in this thing. Okay, we have not done the software architecture for V4. So there is a software component architecture of a client which is important. We have done multi-layer DHT, yes, that's important. We have done a UFS system here, a search engine. There is a mailing system we have done, and we can call it even a messaging. We have done an anonymous messaging system, which was like Talks Chat kind of thing, where there is no user ID. These are all basically user ID based. Let me write down. This is what we have missed out. So it does not matter that you have missed out on all these things. This is kind of an exposure. Now after this, it has to be your own journey to further explore and build up the things on your own. So this has been one of the interesting things which I have learned. Okay, and then of course, yeah, I think more or less. And then of course the onion anonymity part, we have looked into this. And of course, as I mentioned, there is nothing like a unstructured system nowadays. People do go with DHT based routing, so that the networks never get partitioned. That was one of the prominent things. So this is all what basically we have covered, and this has a lot of bearing on us. So tomorrow I think the systems will move in this direction. We will not be requiring servers to do all authentication. We will end up in doing mutual authentication. So, and of course we may not be requiring a lot of servers. Yeah, there's something more which I now recall. We had did peer-to-peer web design, how to create a different kind of web. So where you don't require web servers, those actually can be created here. Yeah, that's the kind of structures which we have done. And since it's a new course, it requires a lot of background and understanding of already communication networks, of computer networks beforehand. And data structures, especially distributed. This is basically an example of distributed systems. And most of it actually has derived from my journey with my own students, how to build this Brihaspati 4. And I think you can always download the code for Brihaspati 4 from GitHub. So this is a continuously evolving work, and from there you can actually keep track of what is happening. You can also contribute to this project. Okay, and I think this is going to grow, and we'll have better version of this whole teaching learning experience going to come in future. So with that, I wish you all the best for the exams which will be happening in the end. We have tried to put up the questions whatever we can with all the stress of pandemic and teaching and other things. So this, and of course if there are deficiencies, and I accept all the responsibility for whatever deficiencies which are there, and please do point out, we'll rectify all these in time to come. Thank you.